Hi everyone, welcome to the course Theory of Computation. In this first video, I will give you a brief background on languages and the Automata Theory and why are we going to study this paper. So let's get started. So first question is that why do we need languages? See, when we grow up in our initial years, we start to learn our mother tongue. We are using our mother tongue to communicate with our family or people around us. And there are certain rules to your mother tongue, but your brain automatically, without giving specific instructions or without specific rules, understands these rules, understands these words. But when you go on into your schooling or you start studying a new language, then you need specific rules to learn that language. For example, if your mother tongue is Hindi, so you will learn, okay, so this particular word means this and so on, and how I am going to form associate verbs with a noun and etc. But when you go to the school and learn English, then you have specifically stated rules. Okay, these words a and the form articles, a, o, u, e, all are vowels. Then there are 26 letters in English alphabet, and how you form the words from that alphabet. What are the possible words in English, or what is the vocabulary of English? You are given specific instructions for that. Then you are being given certain rules. For example, it's never he go, it's he goes. It's never she were dancing, it is always she was dancing. Then they go. These are rules that how you are associating a verb with noun or nouns. So you have specific set of rules which tell you how to form words of a particular language. Then there are certain set of rules which will help you form the sentences, and these sentences will turn meaningful to enable effective communication. But when you move on to machines, when you move on to the computer systems, how do you talk to the computer system, or how do you talk to any machine in general, not necessarily a computer system? How do you talk to any machine in general? How do you get to know whether a particular machine like a computer accepts or rejects an input? And that's where you need automata theory. So automata theory will tell you how to build mathematical models, and from now on we will be calling these models as machines, and not specifically to computer. Any automated device can work on machines because there are various states in which these machines will keep on moving based on the inputs. So you will talk about how to form these mathematical models, then you will study these models to understand what they can or they cannot do. So let me give you an example. Suppose I have a machine like this. Let's assume that there is a machine which I am representing with circles, and let's say there is some initial state, and it starts with your minus. Now there has to be some language which this machine accepts. So if there is a language, then there has to be certain set of letters or certain symbols that this machine will accept. Like in English, you have 26 letters that form an alphabet. Let me call it A and B. Now if I want to tell that this machine only accepts input A, so I will build a mathematical model that if you arrive at an input A, I reach the final state, and this machine can accept a letter or a symbol input A. So you are forming mathematical models to understand what this machine can or cannot do. So language will be a collection of such successful inputs. So it will be a set, and that set of words or set of those inputs which a particular machine can accept. So automata theory will first help you build those mathematical models, then it will help you find out what these mathematical models or machine can or cannot do, then it will help you define a language which is a collection of successful inputs or words that a particular machine can accept. We'll learn more about it later. So then you will have a machine which may have a language, and a language may have a machine. There can be a machine which may not have any language at all, that is, it does not accept any input, and then there will be languages which will be accepted by certain kind of machines, but there can also be languages which do not have any machines to accept them. Yes, we will be studying about such languages and machines also. So there will be certain machines which do not accept or understand anything, which do not accept any given input, and then there will be some very special languages that we will be talking about, that the words in those languages are not accepted by any machines at all. So we will be defining or designing algorithms or automatic procedures to investigate such problems and find solutions to them. So informally you can say it's an interplay, an algorithm is an interplay between languages and machines. So to build mathematical models, mathematical models or machines will help you find out whether a model or machine can do or cannot do something. Then you will find techniques or algorithms that help you arrive at this conclusion. So if a machine can do something, then it will help you design a conclusion whether a machine can do something or not. And if it cannot do something, then it will help you prove why it cannot do something, and it will help you also prove that there will be no machine in the future that will be able to accept a particular language. So if a machine accepts a language, then you will find techniques to prove it. If a machine does not accept a language, you will prove that such techniques don't exist now and they will not exist in the future also. So this is why you will need mathematical models. So in this particular paper, in the theory of computation paper, I will be talking about computability and complexity of a machine. Computability means what languages it can accept, what languages it cannot accept, and their complexity. So this is what this paper is going to be about. I have taken all the references from this book. This particular paper is majorly based on Daniel I. Cohen's book of Introduction to Computer Theory, second edition, published by Wiley, India. And I have taken most of the resource material from this book. You will see a lot of references to this book in the upcoming lectures also. And in the next lecture, I will be talking about the Chomsky hierarchy and why is it important in theory of computation. And if you have any questions, you can ask or write to me in comments. You can like this channel, share it with your friends, and subscribe to this channel to keep learning. Thank you.